wife came up with a solution to get rid of bitter-tasting sediment in her coffee. She punched nail holes in a pot and covered them with blotting paper. Then she placed ground coffee on the paper and filled the pot with hot water. It worked so well that she started selling her coffee filters worldwide. These coffee filters are made of 100% cellulose fiber harvested from slow-growing pine and spruce trees in the forests of southern Scandinavia. The raw material produces paper that lets about 3 ounces of water pass through it in approximately 40 seconds. That's the optimal saturation rate for producing good coffee. 30% of the paper cellulose content is left over from earlier production. The other 70% is raw cellulose fiber. The materials go into a machine called a pulper, which works like a giant food processor. It blends the raw materials with hot water, making a fiber soup called pulp. A paper-making machine spreads a 1-inch layer of pulp across a wire mesh belt. Water jets cut a straight edge on both sides. As moisture drains down through the belt, the pulp forms a soggy sheet of paper. It has a water content of 80%. All this happens at an astounding pace. The machine lays down 1,300 feet of pulp a minute. At the next station, heavy compression rollers squeeze almost half the water out of the paper. A tool applies a crepe texture. This increases the surface area of the paper and improves filtration speed. Next, they use 38 steam-heated rollers to dry the paper completely. The roller surface temperatures are around 250 degrees. As the finished paper exits the machine, a camera registers the location of holes, dirt, or other defects that have to be cut out. It takes the machine 45 minutes to produce an 11-mile-long sheet of coffee filter paper. The roll is transferred to a cutting machine. The paper is sliced into 2-foot rolls so it can fit in the filter-making machine. Sensors in the filter-making machine make sure the paper is aligned correctly. At the machine's first station, tiny needles pierce holes in the paper to enhance the quality of filtration. At the next station, a stamp imprints the company logo in the paper. A knife slices the paper in half, creating 2 side-by-side production lines from this point forward. Each line enters a folding station, where guides fold the flat sheet in half. A roller embosses a seam connecting the 2 layers of paper along the bottom and side. Then a second roller cuts the conical shape of the filter. The machine produces 4,000 filters per minute. The next station cuts the filters apart and collects the leftover paper, which will be recycled into pulp. The filters are sent to an automatic counting machine that divides them into stacks of 80. The machine feeds the stacks to the packaging line. An automated packaging machine aligns each stack with a flattened box. Then it opens the box with a vacuum and inserts the filters. If the machine's sensor detects a problem like filters in the wrong position or missing filters, it ejects that box from the line. This factory produces a few different types of filters. How the cellulose is processed in the pulper determines how the filter will perform. For example, the factory processes cellulose finely to make filters designed to brew strong coffee. Fine cellulose produces paper that drains slowly, keeping the water and coffee beans together longer, resulting in a stronger flavor.